Hello everyone, I'm Vedant Anand along with my group comprising of Amay, Divyansh, Parvati and Sagar here to present on a case study on Fitzroy Gasworks. When ecosystem and humans clash, it is undeniable that pollution will have an adverse effect. Pollution is basically a disease which is incurable but could be prevented. Pollutants can have a huge impact when it enters the environment as a result of a leakage, spill, or accidents, and it will have an interference with the organisms around. Hence, site remediation is a method of removing a soil or groundwater that is contaminated, thus decreasing its impact in the surrounding layers. One such investigation was about Fitzroy Gasworks, famously known for their arc welding methods. Three huge gasometers were built during the 20th century. However, since the 1960s, the area shown in the figure where the gasometers were placed started depleting, raising the level of contaminants. Protection agency was called upon, and Enviro-Pacific agency started carrying out the remediation work. Currently, the council depot area has been remediated, but northern areas still require inclusions. Over to Parvati for the next couple of slides.
Site characterization is a process by which knowledge necessary to conduct risk assessment and design and execute remediation is acquired based on geological, hydrological, and engineering properties of the site. Site characterization is required two times in general during a project. First, prior to utilizing the site for construction of structures to analyze the potential for settlement or leakage. This is the most effective time to undergo site characterization. Second, to inspect the reason of settlement or leakage at the current facility so as to address issues that has cropped up and carry out remediation. Site characterization is thus an essential step in the site remediation strategy as outlined by the flowchart in Figure 2, which provides information such as nature and type of contaminants and their location. Site history. Fitzroy Gasworks was a crucial gas manufacturer from coal to the area under Melbourne around 1861, where the production stopped in 1927. The site operated as a facility to store gas until 1960s. Furthermore, the manufacturing of military hardware and supply of ammonia byproduct for explosives was carried out on the site by the Defense Department during the 1940s. Site investigation. In the first phase, phase 1A of the site remediation, the data from investigations conducted previously was analyzed and a draft remediation action plan was drawn to develop a data gap analysis report. Planning documents were drafted and an independent EPA auditor approved the remediation. In the next stage, phase 1B, the following tasks were carried out. Field visit and site investigation were conducted by heritage consultants, EPA auditor, and other project members. Sample boreholes were drilled using a mobile drilling rig near the three gas holders and in the premises of the buildings present now. Geology was inspected in detail virtually and analyzed after excavating test pits. Soil above important facilities was further tested with the aid of hand augering holes. After studying the results obtained in phase 1B investigation, the remediation action plan was developed and finalized. The plans and necessary documents made by Enviro Pacific was approved by the respective authorities.
To assess the risks involved in the site remediation, a risk assessment matrix was developed in assessing the potentiality of exposure. By looking at the scale of likelihood, it can be said that more emphasis was given to the contaminant threat in the area and to the ecosystem. The major contaminants that were found were light NaPl such as benzene, toluene, and other BTEX compounds, dense NaPl such as coal tar and naphthalene, and other contaminants such as cyanide and ammonia. Other assessments in the matrix involve the threat to the locality, which isn't major until and unless the locals might undergo direct submission to the site, which may cause irritation and inhaling problems. The worker safety was managed well too, with odor control enclosure kits provided to them on site for the work. Over to Amay for the next couple of slides.
So this is like a literature review for the identification of most suitable remediation technology for our site. So initially we researched about few in situ and ex situ remedial technologies for the remediation of Verdal zone. This includes soil vapor extraction, soil flushing, and bioventing. The selection of these technologies is based on the target contaminant, the remediation time, and associated cost. We mostly focus on in situ technologies as they save extra work for transportation, handling of waste, as well as smooth operation. So the first technology we identified was soil vapor extraction, which is mainly suitable for volatile organic compounds such as BTEX and is relatively faster and cost efficient. Then the next technique is soil flushing, which is suitable for volatile organic compounds, semi-volatile organic compounds, fuels, and pesticides. Another technology named bioventing was identified, involves which involves injection of air and nutrients into the unsaturated zone to enhance in situ biodegradation of the contaminants. The studies have found that this technique is efficient in removing dense NaPLs as well as light NaPLs. However, this technique is still at development stage and requires more research. Next. Then we researched about various remediation strategies for groundwater. And according to our site characteristics and contaminants, we found that air sparging and groundwater pump and treat technology could prove to be a feasible options. The air sparging follows similar process to SVE, just the difference is air sparging deals with the contaminants from groundwater. Another technology is pump and treat technology, which is similar to soil flushing. And in summary, after studying this technology separately, it was found that combination of two technologies could be a feasible option, as our site is contaminated with LNAPLs as well as DNAPLs such as coal and naphthalene. The other contaminants, including ammonia and cyanide, were found to be below detection limit, so there is no remedial strategy proposed for these contaminants. Therefore, two remediation strategies were suggested, which include first option is combination of SVE and air sparging, and the second option is soil flushing and pump and treat technology. The combination was based on similarities in operating process and the types of contaminants they remove.
So combination of SVE and air sparging is identified as one of the potential remediation strategies. So the SVE technology is used to remove volatile compounds from the contaminants using airflow. So soil vapor extraction uses airflow due to pressure gradient in the unsaturated zone. The volatile compounds are evaporated and withdrawn by using extraction wells. SVE technology is used to treat large volume of soils in a relatively short period of time and at a reasonable cost. So on the other hand, air sparging is done by injecting pressurized air directly into the groundwater, which causes air bubbles to form and rise along with the contaminants. So air sparging can be used in combination with SVE by first moving the contaminants from the saturated zone into the bazod zone and then extracting of gases by using pumps in the saturated zone.
So the second combination that was looked at is a combination of soil flushing and pump and treat technology. Soil flushing is basically flooding a zone of contamination with an appropriate solution to actually infiltrate the contaminants to the place where pump and treat technology can take over. And pump and treat involves the setting up of various extraction wells where the contaminated groundwater can actually be pumped to the surface to apply surface treatment methods. So to propose a remediation strategy, the following factors were considered. The first factor is the vadose zone contaminants, which has LNAPLs including BTEX compounds. And the saturated zone contaminants includes BTEX as well as DNAPLs, including naphthalene and coal tar. And the geological and hydrological data of the site were also investigated. And the geological data revealed that the site has fine to medium grained soil particles with a hydraulic conductivity ranging from 0.0004 meters per day to 0.44 meters per day. And the hydrological data revealed that the groundwater table was approximately 6 meters below the ground surface. And the direction of the river was, the direction of the groundwater was actually towards the Yarra River. So to conclude, soil flushing in combination with pump and treat technology was suggested as the recommended strategy. And this is the course of action that needs to be followed to execute this strategy. First, the flooding vadose zone with a mixture of water, sodium hydroxide, aerosol surfactant, and an oxidizing agent. Then the contaminated water as well as the volatile contaminants will be pumped to on-site bioreactor for surface treatment. Then the bioreactor will facilitate the breakdown of contaminants using anaerobic digestion. And once that's done, then the water is treated to meet the discharge standards, and it will be reused or discharged into the Yarra River. And the sludge produced from the anaerobic digestion can be sent to the landfills. So the justification for using this strategy is based, the first thing is that the combination of soil vapor extraction and air sparging could also prove to be effective. However, it must be noted that this combination would only target BTEX compounds and not DNAPLs such as coal tar. And the geological site investigation data revealed that the site consists of medium, fine to medium textured soil. Therefore, the high porosity of clay and fine grained soil would act as a barrier for effective vapor extraction. And lastly, the cost of the two combinations was also a deciding factor, and a detailed cost analysis has been looked at in the report. Thank you.